Greetings, ladies and gentlemen. Today I present to you the eBoiler. It's here on the left with our previously advertised iBoiler on the right. While the core price stays the same at 1350 thermium and 150 supercoolant, the eBoiler still provides you with the same output of 11 kilowatts of excess power and 1400 kilograms of sulfur per day as the iBoiler. Still very feature rich with fast and easy startup, hot standby, overclockability, flexible expandability, and extra instrumentation for added reliability and duplicate labor-free maintenance, but now environmentally friendlier. And if you need more power, just build another one. Power your asteroids with a tuxii Industries eBoiler today. Why exactly do you want a sour gas boiler? Well, 11 kilowatts of power is a very good reason, but this also provides you with 400 kilograms per day of sulfur. As you can see, I've got over 75 tons of it there. And you can use that to feed the wildlife in the new DLC. I don't know what sulfur is exactly used for there, but I know it's used. In the base game, sulfur didn't have a use. Another reason that you want to run this is that it's completely renewable. You put in, assuming you use an oil well, you put in 1 kilo of water per second to feed the oil well, and that's if it was running at full capacity. It'll give you over 3 kilos of crude per second, and the system down here is not designed to handle that full capacity. So you won't even be feeding in a full kilo per second of water into this, but you will be getting a full kilo per second of polluted water out of these. Exactly, if you're not feeding in the natural gas from the oil well, it actually produces exactly 1 kilo of polluted water per second, which you could then feed into a sieve and directly feed right back into the oil well if you want to. But the oil well is always going to be kicking out crude oil at 90 C. So preferably you could filter this and feed it to your bristle blossoms or whatever crops you want to feed it to. And then have hot water coming out of, say, a cool steam vent, which it comes out at 110 C steam. You cool that down to 95 C, just enough so that it's liquid, and stuff it into the oil well. Stay tuned to this channel for a cool steam vent tamer from tuxii Industries soon. And yeah, the only thing that is not recoverable from this system is the filtration medium. You'll need 200 grams per second of sand or regolith, if you can get your hands on that, to filter the 1 kilogram of polluted water into normal water if you need it to be filtered. Thank you for your purchase. As you can see, the eBoiler and the iBoiler are very similar. That's why I'm not going to force Abe to go through and build it again, as we did in the last episode. The core difference is you can see that this has 2 thermal regulators instead of a thermal aqua tuner. So you can see 800 kilos of savings there in steel, but we use steel radiant gas pipe. So there's another 125 you have to give back. So it's only 675 steel that you actually save. And, but this also solves the aqua tuners. Like before, we had a problem with the aqua tuner here. It requires a filter gate, and it doesn't quite run ideally with an aqua tuner. So we actually solved that by using the thermal regulators and pumping hydrogen through it. You can set this to whatever you want. No filter gate required because it's hydrogen. It's not gonna freeze in the pipes. We don't care if it gets cooled down to minus 100 if it needs to get the job done. It's not going to affect anything. Whereas here, if this does a double freeze on the salt water or a double tune on the salt water, it can break the pipe behind the aqua tuner right there. So that's kind of what I was getting at. Not to mention we had a guy nagging, hey, we can do this with regulators. We can do this with regulators. We tested it, and at the time it just didn't work. But now that we've refined this down to this, you can see it's working just fine right here. So here's a viable option if you're not going to be pulling cooling off your aqua tuner to do major cooling work. Then you can easily do this with a self-contained unit here, and you still might be able to steal some cooling off here. And with a design like this up here, you can steal cooling off the bottom as well. So that's always an option. We solved the heat leakage problem that the iBoiler had. You can see it here. We double insulated. This is just the hottest part of the wall. It doesn't completely solve it. We're in vacuum here, so it doesn't matter. If you build this in a vacuum, it won't matter. But if you're not building this in a vacuum and you're kind of worried about your environment getting hot, you definitely want to insulate this side of the iBoiler or the eBoiler. And I've also taken out the temperature shift plates and put in bridges. This isn't necessary. It'll just stop heat from getting pushed as much into these insulated tiles. But temperature shift plates will still work in these spots as previously advertised and made, as you can see up here. Not up there, over here. This one still has temperature shift plates. You still need one bridge to go on this diamond tile. That's just required because you kind of need a temperature shift plate to be on the diamond tile, and you can't do that with a solid tile. And also another thing that we recommend for heat leakage is before I was thinking that we could save 1.8 tons of material by not insulating this pipe, but the material in this pipe will heat up the insulated tiles even more, and then that heat can in turn leak into your environment. So, you know, who doesn't have an extra 1.8 tons of igneous rock or whatever you made these pipes out of? It could be anything. You know, sandstone would work, and just insulate these pipes. We added in these corner moldings on the outside, so you know this is now a 25% prettier machine. Another thing for cooling that this application might actually be slightly better for is if you wanted to use this to cool down food. It's very easy to make a setup where like you could cool this. You can cool the top area up here down to -30 if you want, especially using this. But you could do it with crude and petroleum as well, and still freeze this to -30 and have another chamber over here, like even right here, where you store your food in a carbon dioxide or chlorine or even vacuum, and just flash freeze your food using this system. Odds are you've got food solved by the time you built this though. I'm going to show you the power now. As you can see here, I never did show you before the iBoiler's actual circuit, but you can see here that it takes 3 circuits. You've got, I don't want to run heavy watt power in here because it would just get too complicated with insulating and the multiple different chambers of heat that we're trying to do. So it's just better to use 2 kilowatt wire. So what I did on the iBoiler is you can see that I've got 3 circuits coming down, and you need 3 large power transformers. I just used a small power transformer down here for the tepodizer and the pump, just to demonstrate you can. But considering that they're both 200 kilograms of whatever they're made out of anyway, like if you wanted to use copper ore to make this rather than copper, I would recommend using a large transformer, but this shows that it can be done with a small power transformer for the bottom circuit. But with the eBoiler, we're able to get it down to just 2 circuits. Up here, we've got the Thermo Regulator and the Aqua Tuner all on the same circuit, and it's able to do the job just fine. So that's one way that we were able to conserve a little bit more, and you won't have another power transformer bleeding heat off into the environment as well. One concession that we did make is we crank this up to basically once a cycle. This is going to pick up the sulfur, and it just reduces the load on the circuit because, you know, this is only active for 8 seconds a cycle, and this is only active, but like this only loads in 1 ton at most of material into this, and this is only active until it empties. So it reduces the load on the circuit. Without this timer, this auto sweeper will be constantly picking up your sulfur and providing electrical load with no added benefit. So there's that. As expected, both of these, you can see the uptime is expected to be about 71%. I know these say 72, 73%, but I'm just telling you, in my experience, you can expect 21%, 71%, and if you don't have 71%, you know, your Oni might be running a little bit funky for you or something. It does fluctuate, but it will average out at 71%. And if it doesn't, you might have missed a bridge or something like that if you don't see the same efficiency in the design. Cobalt pipes are now a thing in the DLC I've heard about, and I think you could probably replace all of these pipes with cobalt and not see an appreciable difference. There would be a difference, but I'm not sure. For the 3 critical pipes down here, cobalt still, I don't think it's good enough at 200 thermal conductivity. A radiant pipe made out of cobalt will have 200 thermal conductivity, whereas aluminum is at 410 and thermium is at 440, if I recall correctly. And yeah, 440. And just for this, I like to use those 3 pipes. But the rest of this, you could use anything, not lead, but you could use cobalt, copper, gold, iron. You know, if you can make the pipes out of diamond, I think that would work too. Cobalt also is an interesting material in that all of the diamond stuff in here you could rebuild with cobalt, since diamond might be harder to get in the DLC than cobalt. So, you know, there's another idea for you. Now we'll talk about the not there, over here. The options. The options haven't changed too much. You know, you still have to space them out, or you will have to space out the top ones. But the bottom, you can still bleed off heat. You know, you can still relocate the sensor over here and isolate these two and bleed heat off out of your sour gas boiler. You could even build the whole thing in a water tank and install a system like this on the bottom and bleed the heat, all of it, off into a water tank rather than having a tepidizer here altogether. Again, we have our deletion package. You don't need to use as many doors and whatnot down here, but you won't have control over the pipe, the supercoolant in the pipe as easily. I will demonstrate. We do have, this is our now changed hybrid package. Wait, we need to delete a couple tiles over here. These 2 tiles got to go, not that one. Oh, crap. Oops. You didn't see that. Here at Tuxie Industries, we run a tight ship. Now, to demonstrate this, we're just going to take this. We pop it in right here. Boom. Obviously, you'd put in a liquid lock right here, and but this allows you obviously take out a couple tiles here to let or you could take out this tile, put in an airflow tile there to let the sour gas, well, the natural gas mainly, but the sour gas is going to get into. You have a liquid lock here. When you're done construction, you can seal it in like that so that the temperature doesn't bleed out really horribly, because this will be 200 degrees, and you set this to natural gas, obviously. And then your natural gas floats on top of the sour gas. It'll float up here, and you could pump it out if you want to. Once the system stabilizes, though, you can see here that, this is stabilized. There's no natural gas. Once this is running, most of the time, this is, it's not really necessary, and that's why I haven't put it in the build. Now, if you wanted to extend the cooling loop of the iBoiler, we've modified this so that it goes like this now. The tank is no longer in the hot chamber. It wouldn't make a big difference, but this is just isolate your cooling from this heat a little bit more, even though a tank doesn't really transfer temperature from its environment into the liquid that easily. So here it is. You'd have it come out. It cools the steam turbine first, and then it goes out into your base. This is the input for your base. That's what this bridge represents. It's coming back from base. It goes into the tank, and then it comes out of the tank here, and then immediately hits the sensor. You can delete the filter gate. The filter gate is no longer required. So, or if you don't want to break in here, you can just set it to close to 0. Thanks again for your patronage to Tuxie Industries, and please be sure to like and subscribe to stay up to date with our products. We welcome all feedback. If you're interested in the development history of the I and E boilers, more products from Tuxie Industries, or if you want to see me demonstrate a boiler in survival mode, be sure to sound off in the comments below. I hope you get many cycles of faithful service from your eBoiler. Complaints and refund requests can be mailed to 50,000 Shattered Planet Way. Here are the schematics. The save and blueprints are linked below. Thanks for watching, and I hope you were informed, entertained, or both. Catch you next time.